A pleasant day to all the viewers. This is Hannah Vinchal Igoy, Ferdinand Leiras, and Rona Marie Manggubat of Group 4 from PS Matay 1 at your service. Today, we will be discussing sampling distribution. But let us know first the goals or objectives of this lecture video. At the end of this lecture video, we should all be able to attain these objectives. First on the list, understand the concept of sampling distribution. Second, describe the sampling distribution of the sample mean and sample proportion. And lastly, apply the central limit theorem to calculate approximate probabilities for sample means and sample proportions. So now let us proceed to our topic. What is sampling distribution? And how does it differ from the population distribution? Sampling distribution of a statistic is a probability distribution based on a large number of samples of size n from a given population. So, sampling distribution refers to the distribution of a sample statistics that would result from taking multiple samples from a population. So, kung ako'y paistoryahon, ang sampling distribution is based on the idea na if we were to draw multiple random samples from the same population and we calculate the particular statistic like the sample mean or the sample standard deviation for every sample, the collection of this statistic would form the sampling distribution. Mao na siya ang pagsabot sa sampling distribution. So, the population distribution on the other hand is the probability distribution of the population data. It also refers to the distribution of a specific characteristic or variable within an entire population. Nagrepresent siya sa complete set of data or values for a particular variable for every element of the population. So to understand more, we provided examples. For example, sa population distribution, if you're interested in the heights of all students in your school, the distribution of heights for every student in the school would constitute the population distribution. So, kung ako daw is interested ko sa height sa tanang estudyante sa City Main Campus, ang distribution ko sa tagsa-tagsa ka height sa mga estudyante sa City Main, maoy mo purma sa population distribution. So, sa kani nga problem, ang population diri is ang tanang estudyante sa City Main Campus. Unya, ang variable of interest is ang tagsa-tagsa nila nga heights or the heights of the students. Dayon, ang population distribution diri is the distribution of heights for every student in the City Main Campus. But, if ako dyan siyang buhaton, it might not always be feasible to collect the data or measure the data from the entire population of City Main Campus due to time factor, cost, and other constraints. So, diri na mosulod si sampling distribution. So, ibutang talang na I still want to estimate the average height of students in our campus. Kay average man ang gipangita, ang gamito na to nga statistic is the mean. So, from the entire student population of City Main Campus, magkuha ra kog multiple random samples of 30 students each and calculate the average heights in each sample. Ang collection of the average heights nga ako makuha from the different samples, maoy mupurma sa sampling distribution of the sample mean. Sample mean kay mean man ang gigamit, average ang gipangita. So, this shows how much the calculated average heights vary across these samples. So, in summary, the difference between population distribution and the sampling distribution is that the population distribution encompasses all data points in a population, and the sampling distribution pertains to the distribution of sample statistics obtained from multiple samples drawn from a population. To proceed, there are different types of sampling distributions, but we mainly focus on the sampling distribution of the sample mean and the sampling distribution of the sample proportion. Kaya naghisgot naman tag sample mean sa ating example, here we have Ferdinand Leiras to explain further the sampling distribution of the sample mean.
In lesson 1.1, we have the sampling distribution of the sample mean. So what is a sampling distribution of a sample mean? It is a frequency distribution using the means that is computed from all possible random samples of a specific size taken from the population. So there are properties of the sampling distribution of sample means. So first, we have the mean of the sampling distribution of X is always equal to the mean of the population. Thus, mu sub X bar is equals to mu. So the formula of getting the mean of the sampling distribution is equals to the summation of X bar over N, where the X bar represents the sample mean and the N is the total number of observations. And the second properties of sampling distribution of sample mean is the standard deviation. The standard deviation of the sampling distribution of sample mean is given by the sigma over the square root of n, where the sigma is the population standard deviation and the n is the sample size. So take note that the standard deviation of the sampling distribution of the sample mean is called the standard error of mean. So there are steps in constructing the sampling distribution of the means. First, we have to compute the population mean. Second is to compute the population variance. Third is to compute the standard deviation. And the fourth one is to list all the possible samples and their corresponding means. Next is to construct the sampling distribution of the sample mean. The next one is to compute the variance and standard deviation of the sampling distribution of means. And the last one is the constructing of a histogram. So we have here an example 1.1. Suppose we have a population with the following values 3, 6, 9, 5. We want to create a sample size of 2 with replacement. So list all the possible sample size of 2 and find the mean, variance, and standard deviation of the sampling distribution of the sample means. From the steps that I had said earlier, the first thing that we need to do is to compute the population mean. So we have the formula of mu is equals to summation of x over n, where the x is the sum of all values in the given data and the n is the total number of the values in the given data. So we have here the x, we have 3, 6, 9, 5, and the n, or the total number of the values in the data, is equals to 4. So after adding it all, we will have the answer of 23 over 4 and will results to 5.75. So that would be our population mean. The second step is to compute the population variance. So in getting the population variance, we have the formula of sigma squared is equals to summation of x minus mu squared over n. So here, the first thing that we need to do is to put all the x in the table. We have 3, 6, 9, and 5. And then, i-minus nimo ang first value sa imong x, which is 3, sa mu, which is 5.75. So we have here 3 minus 5.75, which is equal to negative 2.75, and then squared nimo siya, so you will have an answer of 7.56. So same process sa gyapon siya, i-minus nimo ang 6 sa mu, which is 5.75. So we have here 6 minus 5.75, we have 0.25, and then squared nimo siya, so we have an answer of 0.06. So same process lang gihapon ang imong buhaton sa all other x values. So after that one, imong kuhaon ang summation sa x minus mu squared. So we have 7.56 plus 0.06 plus 10.56 plus 0.56, so we have the answer of 18.74. Since nakuha na nimo ang summation of x minus mu squared, which is 18.74, so mabalik ka sa formula of getting the population variance, which is summation of x minus mu squared over n. So we have 18.74 over n, where ang n nimo is the total number of the elements in the given data, which is equal to 4. So we have 18.74 over 4. So that would give us the answer of 4.685. And that 4.685 is our population variance. So the third step in constructing the sampling distribution of the sample means is to compute the population standard deviation. So the formula of getting the population standard deviation, we have the square root of the population variance. Since we have the value or the answer for the population variance, which is 4.685, squared na lang na siya nimo, and that would give us the answer of 2.16, and that 2.16 mo na siya ang answer nato sa population standard deviation. So next is to list all the possible samples and their corresponding means. Since our problem is with replacement, so may possibilities na magbalik-balik yung numbers. So our sample size is equal to 2 man. So we have 33, 36, 39, 35, 63, 66, 69, 65, 93, 96, 99, 95, 53, 56, 59, and 55. So after listing all the possible samples, kuhaon na to ang ilang corresponding means. So the first sample that we have is 33. So 3 plus 3 all over 2, since duha ra man na sila ka value, so 3 plus 3 over 2, that would give us the answer of 3. So same process, we have 3 plus 6 over 2, and that would give us the answer of 4.5. After getting all the corresponding means of each sample, isum up nimo na siya. So we have the summation of x bar is equals to 92. And then, kuhaon nimo ang mean of the sampling distribution. And in getting that, we have the formula of mu sub x bar is equals the summation of x bar over n. Since we have the value na of x, summation of x bar, which is 92, all over n. So, ang n na today, mo na siya ang total number of elements in the sample. So, the total elements in the sample, we have 16. So, 92 divided by 16, that would give us the answer of 5.75. So, therefore, our mean of the sampling distribution is equals to the population mean, which is 5.75. The next step is to construct the sampling distribution of the sample means. Since we have the list of all the samples and the corresponding means of each sample, the next thing that we need to do is to get the sample means, frequency, and probability. So here, mag-start ta sa pinakagamay nga value, and then kuhaon nimong frequency and probability. So here we have 3. So ihapon nimo pila ka buok 3. So 3, we have 1. So, ang probability ana niya is 1 over 16. Nganong 1 over 16 man? Since iyang frequency kay 1 ra. And then, ang n man, sa total tanan samples, nga naan mo is 16. Mo na siya 1 over 16, and that would give us the answer of 0.625. So, same process lang gihapon. We have 4. So, pila ka buok 4. Ihapon nimo pila ka buok 4. So, we have 2. So, 2 over 16, and that would give us the answer of 0.25, and so on. So, after that one, itotal nimo tanan frequency. So, ang dapat ang frequency is ma-equal siya sa n, which is 16. So, we have here 16. So, check. So, ang probability, dapat i-total nimo sa tanan probability, ma-equal siya sa 1. Because, mo na ang rule sa probability nga, dapat mo equal siya sa 1. The next step is to compute the variance and standard deviation of the sampling distribution of means. So, una, we will get the variance of the sampling distribution. So, ang formula of getting the variance of the sampling distribution is equals to sigma squared over n, so, where the sigma squared is the population variance and n is the sample size. Since we already have the value of the population variance, which is 4.685, divided by n, which is the sample size nato, that would equal to 2. So, 4.685 over 2, and that would give us the answer of 2.34. Next is to get the standard deviation of the sampling distribution. So the formula of getting the standard deviation of the sampling distribution, we have the sigma over the square root of n. So the sigma is the population standard deviation over n, where n is the sample size. So we already have the answer for the population standard deviation, which is 2.16. So 2.16 divided by the square root of 2, and that would give us the answer of 1.53. So the last part is to construct a histogram. So in constructing the histogram, ang x-axis is the sample mean and the y-axis is the probability. So we have here the sample mean 3, 4, 4.5, 5, 5.5, 6, 7, 7.5, and then 9. So in plotting that one, itanawon na nimo ang probability. So, ang 3, na belong siya sa 1 over 16. So, 1 over 16. And then, 4, na belong siya sa 2 over 16. 2 over 16. Then, sa 4.5, 4.5, na belong siya sa 2.16. And then, the 5, na belong siya sa 1 over 16, and so on. So, mora na siya ang pag-construct sa histogram. So, the next lesson is the sampling error. So, what is a sampling error? So, sampling error is the difference between the value of a sample statistic and the value corresponding the population parameter. So, the formula of getting the sampling error is equals to x bar over mu. So, we have here an example. Suppose we have a population with the following values 3695. We want to create the sample size of n is equals to 2 and then find the sampling error. So, we already know ang x bar is mo na siya ang sample mean, and then ang mu is the population mean. So, ang sample mean changes na siya depending on the sample that we take. And then the population mean always the same na siya no matter how many times we tried to calculate it. So we have here the solution. First, we need to get the population mean. So we have 3 plus 6 plus 9 plus 5 over 4. And that would give us the answer of 5.75. So now, we take a particular sample of 2, let's say 9 and 5. Then let us calculate the mean for this sample. So we have 9 plus 5 over 2. And that would give us the answer of 7. And then after that one, using the sampling error formula, which is the x bar over mu, and that would give us 7 minus 5.75, and the answer for that is 1.25, and that 1.25 is our sampling error.
The shape of the sampling distribution of sample mean has two cases. The first case states that the population from which samples are drawn has a normal distribution, while the second case is the total opposite of the first case. Yan naman, it is because it states that the population from which samples are drawn does not have a normal distribution kuno. Now, let's discuss first the first case, which is the sampling from a normally distributed population. So, when the population from which samples are drawn is normally distributed with its mean equal to mu, and the standard deviation equal to sigma, then the mean of the sample mean is equal to the mean of the population, and the standard deviation of the sample mean is equal to the standard deviation divided by the square root of the sample size, assuming that the ratio of the sample size to the population size is less than or equal to 0.05. Lastly, whatever the value of the sample size, the shape of the sampling distribution of the sample mean is still normal. So, guys, ang idea ra jud aning first case kay if ang population nga atong gikuhaan sa samples kay normally distributed, then ang sampling distribution of the sample mean kay normally distributed sad, with the following mean and standard deviation irrespective of the sample size. To picture out, we have here figures to show the concept of case number 1. So sa inyong nakita, ingana ang shapes sa probability distribution, same siya sa shapes sa sampling distribution nga gaporma og bell shape or bell curve. Kung nakabantay sad mo, natay 5 ka figures. Ang figure letter A, which is the upper figure in the picture, shows a normally distributed population distribution curve. Kanang sa ubos gikan sa ikaduha nga figure, letter B, paubos hangtod sa ikalima figure letter E, mao na ang sampling distributions of the sample mean. Pero, lalahi lang ang sample sizes nga gikuha gikan sa population distribution, na ay 5, 16, 30, o 100. Kay normally distributed man ang population distribution nga atong gikuhaan sa samples, ibig sabihin, ang sampling distribution of the sample mean is also normal for each of the 4 cases illustrated in figure letter B hangtod sa figure letter E. Please also look at the spread of the sampling distribution of the sample mean. Kung nakabantay mo, it's decreasing as the sample size increases. So to conclude, the case 1 states that if the population distribution is normally distributed, the sampling distribution of the sample mean is also distributed normally, and as its sample size increases, the spread of the bell curve decreases. Now, let's proceed to case number 2, which is sampling from a population that is not normally distributed. Case number 2 is sampling from a population that is not normally distributed. So, most of the time kuno, the population from which the samples are selected is not normally distributed jud. For instances like this, the shape of the sampling distribution of the sample mean is determined based on a highly significant theorem known as the central limit theorem. So, unsa naman pud ni ang central limit theorem, guys? The central limit theorem is a theorem that forms the foundation for the inferential branch of statistics and describes the relationship between the sampling distribution of sample means and the population that the samples are taken from. So, the theorem is the idea of how the shape of the sampling distribution will be normalized as the sample size increases. Ang central limit theorem kuno, guys, kay makatabang siya sa pag-construct sa sampling distribution of the sample mean, unya magamit ni siya if ang population kay dili normally distributed. Halimbawa, ang weight or income sa usa ka region. So let's explain further the connection of central limit theorem to case number 2, sampling from a population that is not normally distributed. The central limit theorem states that when you take multiple random samples from a population, the distribution of the sample means will tend to approximate a normal distribution, regardless of the shape of the original population distribution. So specifically, as the sample size becomes sufficiently large, the sampling distribution of the sample mean will approach a normal distribution. Therefore, according sa theorem, kung increase galing ang sample size, mo-decrease sab ang spread or variability sa sample means around the population mean. Tungod kay ang standard deviation sa sampling distribution sa sample mean, muubos man sad or mo-decrease. This leads to a narrower and more concentrated normal distribution around the population mean. Note that when the population does not have a normal distribution, the shape of the sampling distribution is not exactly normal, pero it is approximately normal for a large sample size. The approximation becomes more accurate as the sample size increases. So another point to remember is that the central limit theorem applies only to large samples. And usually, ang sample size na 30 or more ang mao'y considered nga sufficiently large and that it can be applied to the sampling distribution of sample mean. And regarding sa properties sa case number 2, same ra sila sa first o second property sa case number 1, which is the mean of the sample mean is equal to the population mean. And the standard deviation of the sample mean is equal to the standard deviation divided by the square root of the sample size, assuming that the ratio of the sample size to the population size is less than or equal to 0.05. However, on the third property, dili lang sila pareha because here sa case number 2, according sa central limit theorem, kung ang sample size is greater than or equal to 30, ang shape sa sampling distribution of the sample mean is approximately normal irrespective of the shape of the population distribution. Note that the greater the sample size, the better the approximation. Thank you. Para maka-visualize mo, we have here figures to show the concept of the case number 2. Naagyapon tayo 5 figures. Ang figure letter A, which is the upper figure in the picture, maagyapon na siya ang population distribution curve, but dili na siya normally distributed. Kanang sa ubos, gikan sa ikaduha nga figure letter B hangtod sa figure letter A, mauna ang sampling distributions of the sample mean, pero lahi-lahi gyapon ang sample sizes nga gikuha gikan sa population distribution. Naatay 4, 15, 30 ug 80 nga sample sizes. Kung nakabantay mo, ang figure letter B ug C kay less than 30 ang iyang sample size which is 4 ug 15. Maong dili considered normal ang ihang sampling distribution. Pero sa figure letter D ug E, approximately normal siya kay ang iyang sample size more than or equal to 30 man. Common gihapon sa case number 1 ug number 2 nga ang spread sa bell curve ga decreases kung ang iyang sample size mo increase. Now, let us jump to the next type of sampling distribution, the sampling distribution of sample proportion to be discussed by Hannah Vinchal Igway.
What is population and sample proportion? The population proportion, denoted by P, is obtained by taking the ratio of the number of elements in a population, while the sample proportion, denoted by P hat, gives similar ratio for a sample, or P hat equals X over N for sample proportion. There are capital N here is the total numbers of elements in the population, and small letter n is the total number of elements in the sample. Then capital X is the number of elements in the population that possesses specific characteristics. And lastly, the smaller letter x is the number of elements in the sample that possesses a specific characteristics. For example, let's consider a hypothetical scenario of a classroom with 30 students. Suppose we want to find out the proportion of students who prefer studying in mathematics. Let's say out of the 30 students, 18 students prefer studying in mathematics. So in this scenario, our population here refers to the entire group of interest, which is kaning 30 ka students sa classroom. Then our population proportion is the ratio of students who prefer studying in mathematics out of the total 30 students. So kaning example, makita na to nga 30 ka buok ang students, 30 ka buok nga students, 18 ani nila ang prefer mo study og math. Therefore, the population proportion of math-loving students in the entire classroom is calculated as 18 divided by 30, which has the result of 0.6, and it is equivalent to 60%. So, sa sample na sadta, pero pareha ra og scenario dito sa pikas nga example. So, suppose out of 10 students surveyed, 7 students prefer studying mathematics. We all know that sample is a subset of the population that is studied to draw conclusion about the entire population. In this case, a sample of 10 students was randomly chosen from the classroom, and these 10 students were asked about their preference for studying mathematics. Then among these 10 students surveyed, 7 students expressed a preference for studying mathematics. So our sample proportion here is 7 divided by 10, which has a result of 0.7 or 70%. Therefore, our population proportion is 60% of the entire classroom. prefer studying math, while sample proportion is 70% of the 10 surveyed students prefer studying mathematics. So, what is sampling distribution for our sample proportion? It is the distribution formed when sample proportions of size n are repeatedly taken from a population where the probability of an individual with a specified characteristics is p. Now, to select a simple random sample from a large population with population proportion or p hat of a similar characteristics as the sample, then our mu here, or the mean of the proportion, is equals or the same as the population proportion. And our standard deviation for our sample proportion here is given by the formula of square root of PQ all over the n.
Let us now proceed to the central limit theorem for sample proportion. So according to this theorem, in the realm of proportions, the sampling distribution of the sample proportion becomes approximately normal for a sample size that is considered sufficiently large, specifically when both NP and NQ are greater than 5. That is when the sample size is deemed sufficiently large. Note that NP means the product of the sample size and the proportion of successes, and NQ means the product of the sample size and the proportions of failures. Let us note that the sampling distribution of sample proportion is dili jud siya exactly normal. However, as the sample size increases, the sampling distribution of sample proportion becomes approximately normal sad. The normal approximation is most accurate for any fixed sample size when the proportion of successes is close to 0.5, and least accurate when the proportion of successes is near 0 or near 1.
For example, a simple random sample of 1,500 college freshmen, whereas if they applied admission in another universities. It's a known fact that 35% of all college freshmen applied to other universities aside from they are attending to. What is the probability of 1,500 sample will give result with this 2 percentage point of this true value? So first, we need to find the proportion mu and the standard deviation of the problem. So sa formula I showed you earlier, it state that proportion is equal sa atong estimated nga mean for its proportion. So, ang P nato diri nga 35%, which is the population proportion, will be our sample mean, and it will be 0.35. And to get our standard deviation, we use the probability of normal probability. So, naman tay P, which is the given proportion nga 0.35, then the Q will be the complement of our P, which is 1 minus 0.35. And it is equal to 0.65. Then mauna ni siyang 0.35 times 0.65 all over the sample size of 1,500. Then, take the square root of this para makuha na natong standard deviation, which is 0.0123. So now, naana tayo 0.35 nga mean o standard deviation for our probability answers. So, mao na ang atong illustration sa atong problem nga kung unsa daw ang maging probability nga gikan sa 1,500 sample size nga atong result is ma-fall within 2 percentage point from the 2 mean. So, to find the area under the curve, we need the normal distribution with the probability of x between the 0.33 and 0.37. Then mean nato nga 0.35 with a standard deviation of 0.0123. With the use of calculator, we have the result of 0.8961. Therefore, about 90% because 8961 closes to 90%. So about 90% of the 1,500 college freshmen will give result within 2% of the true proportion. Thank you.
Importance of sampling distribution. We all know that populations are typically large in size. That's why it is important for us to use a sampling distribution so that we can randomly select a subset of the entire population. Doing so will help eliminate variability when we are doing research or gathering statistical data. It also helps make the data easier to manage and builds a foundation for statistical inferencing. Furthermore, the concept of sampling distribution holds immense significance across various domains like decision-making, scientific research, and everyday situations where statistical inference is pivotal. For instance, governments and policymakers leverage sampling distribution to collect data, analyze societal trends, and formulate policies pertaining to healthcare, education, infrastructure, and more. In summary, the concept of sampling distribution is very important as it forms a cornerstone